Hi there. In this video, we're going to talk about describing one numerical variable. So we are getting into what's called descriptive statistics. So let me write that down. So descriptive statistics means describing a data set, describing the data you have. Okay, we're not getting to inferential yet. This is descriptive. And we have a framework to describe data, and we're looking at a single quantitative variable. So just one numerical or quantitative variable. We want to describe 6 things, really. We've got the shape, and we'll talk about all these. The shape, center and spread go together. Unusual features, we want to include units and context. Okay, so all this is important. The numbers are meaningless by themselves. We need the units, we need the context, and we're going to go through all of these items in this series of videos. Okay, so let's start with shape. We do that one first for a reason. We're going to use this example data set down here, which are, it's made up data, a set of exam scores, 15 scores, for a fictional Stat 243 class. And you might notice by looking at the numbers, it's hard to really tell what's going on. You might see, okay, one looks lower than the rest, but we really want a picture to see what's going on with the data. And so that helps us determine the shape. Okay, so a question for the shape is, how are the data distributed? We need to see a picture to determine the shape. Okay, so there are 4 different types of graphs that we'll look at for a quantitative variable, and we'll do 3 of them in this video. A dot plot, a stem and leaf plot, and a histogram. So we're going to cover those in this video, and then the box plot will come a little bit later on. You may have seen some of these before. Descriptive statistics might be familiar to you, but I'm not assuming any prior knowledge, okay? Just like with our vocabulary. Okay, so let's take a look at this data and draw a dot plot first. And then we will be using technology. So we'll usually have bigger data sets, more meaningful data sets. And so we're going to use technology. But it's nice to do it by hand one time so you understand what the computer is doing. And then we'll be using an app called Statlet. So I'll show you that in the next video. Okay, so here's my axis. You could draw it by hand, or I've got one on the notes here, and we need to make a scale. So I'm noticing the data goes from about 30 to 100. So I'm going to start with 30, and I'm going to go by tens. I'm just going to kind of estimate how to get up to 100, 40, 50, 60, 70, 80, 90, 100. Okay, and very important to always label what we are doing. Okay, so we've got 15. Now I could put this above or below. 15 exam scores. And I'm going to put points because these are in points. Okay, so a dot plot, and we've actually already seen an example of this in our simulation when they did the coin flips, calculated the proportion, and then dropped a dot down on the dot plot. So you're a little bit familiar with this already, but we'll just go ahead and make one. Now let me label a little bit: 30, 40, 50, 60, 70, 80. I should have left myself a little more room there. 31 is going to be just past 30. So I'm going to put a dot. It also could be an X or a square, whatever you want. Then 62 is going to be a little past 60. 65 is going to be right in the middle. 70 is going to be right on 70. 76, a little past halfway. 81. 82, I'm going to squeeze it in there. Another 82. Okay, so the thing about a dot plot is when you get a repeat, you stack it up. Okay, 82, then 87. Got to squeeze my 87, 88, and 89 all in here. 94 is just under halfway. 95, 98, and 100. Okay, so it's a little rough because it's by hand, but And then we might also put like stat 243 test scores. Okay, so we've got our little bit of our context, what the variable is, and what the units are. So let me write those labels down. And I'm really big on labels and communication around statistics. And part of the reason for this is I was a statistical analyst at Saturn. And when I took over for a person before me, there was a whole a whole drawer of graphs and charts and, reports and things, and nothing was labeled. There was no date, there was no title, there was no context. So it all was pretty much useless because there wasn't anything there that would tell me what it was about. So it's part of the reason why I'm so passionate about labeling, but also it's about communication, because we really can't expect that anyone else understands statistics. So even when I worked in the auto industry, I would talk with managers or other team members, and it was clear to me that they maybe didn't quite understand the statistics. So communication also helps other people. It helps other people understand what we're doing. Okay, so it helps us and it helps others. So things we're going to label, we want to always have the context as much as we have. We won't always have the full context because we have homework questions, but as much context as we have, the variable, and then we have the units. Okay, so units are the units of measurement, and this is stat 243, that's part of the context, and then the test scores or exam scores, that's the actual variable. And I'll show you how to label this in the online app as well. Okay, so that's our dot plot. Now the stem and leaf plot is similar, but the thing that's unique about a stem and leaf plot, and the thing that's nice about it, is it actually keeps the data, so we can actually see the data right in the graph. I wouldn't want to do this for a super large graph, but we can do it for a small data set. And this might be something, if I had I used to do this actually, if I had exam scores and they were a little bit, I made the test too hard, and then I was like, well, I might need to adjust. I would graph it out to see where all the scores were. So I actually would use this. So I'm going to start similar to 30 to 100, and we're going to use usually one digit or a set of digits as the stem, and then these will be the leaves over here. Okay, so these are the stems. And then over here will be the leaves. So for the data point 31, 3 is the stem and 1 is the leaf. And then I'm going to we need our even scale, just like here. We can't skip numbers just because there isn't any there. 3, 4, 5, 6, 7, 8, 9, and 10 is going to have, 100 is going to have a double, 2-digit stem. Okay, so then 31, my next data point is 62. So what this does, just like here, it shows us there's a gap in the data. So 62, and then there's another 60, 65, and then 70. And I'm trying to make my numbers evenly spaced so that it's almost like a dot stacking up, right, in that, but now we're going by tens instead of ones. So 70, 76. Okay, that's it for the 70s. Now we're going to 81, 82, 82, 87, 88, 89. Okay, now I'm starting to see some shape. There's a lot in the 80s. Oops, sorry, I need to bring this up. 89, 94, 95, 98, and then 100. Okay, again, we need to label it. I didn't leave myself too much room at the top, so I'm going to use the bottom. Math, or actually stat 243 test scores in points. Okay. Now, also, it's nice to make a little key on this because is this 3.1 or 31 or 0.31? So this, you can really use any decimal, use this with any place value. You just got to show what it is. So for our little key, is usually written like this: 3, and then a slash for the bar here is 31. But it could be 310, or it could be, it could be anywhere with those digits 3 and 1. Okay, so that's our stem and leaf plot. And again, we'll be using technology, but just want to show you how it works, so you know how it works. Okay, so then that's our stem and leaf plot. Now we're going to do a histogram, and we'll kind of look at how these are related. Okay, sketch the corresponding histogram for this data using a bin width of 10. Scale and label your graph appropriately. Okay, also I forgot to read over here. It told us using the tens digit as the stem and the ones digit as the leaves. So this actually is a bin width of 10 as well, because we went 30, 40, 50, 60, 70. So I'm going to do a similar thing here. I'm going to start with 30, 40, 50, 60, 70, 80, 90, 100. Okay. I could have started with 0, 30, 40, 50. Okay, just making sure I didn't forget one. We could start with 0, and that's important if you're comparing two graphs, to start with 0 so you don't get any distortion. But when it's a single graph, it's okay if we start here. And then on a histogram, we have frequency going up. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, and hopefully we won't get any higher than that. And I'm going to label this. I have to turn the paper for a second here. I'm going to label this frequency. That's my vertical axis. It's a count. It's how many of our subjects are in that bar. And then down here, I'm going to write stat 243 test scores in points. Okay, great. So I'm going to, my data's off the screen, I know, but I'm going to go back up to the data. Our first number is 31. So that's going to be one whole square. And I'm going to shade it like that with hash marks instead of coloring in the entire thing. And then we go up to 62. So 62 is between 60 and 70. So each width here is called a bin, or sometimes called a class. Class width is another term you'll hear for that. Bin or class. Then 62, so I'm going to go one square between 60 and 70, and 65 is another square. I'm going to shade both of those. 70, there are also two numbers in the 70s. There's 70 and 76. So I'm going to just go across. You might notice I'm making my bars touch. So in a histogram, there is no space between the bars, just like there's no space between, the numbers. There's not a gap, like this is just 70 right here, so there's no space. Later when we get to a bar chart, we'll see that there is space between a bar chart bars. But this, because it's numerical, this is a continuous scale here. So we've got two 70s. Where am I on the 80s? 1, 2, 3, 4, 5, 6 80s. So I've got to go all the way up to 6 and draw this bar. Notice how the bar does say 80 to 90, but a 90 is going to go in the bar to the right. So as long as you're consistent, there's different rules for this, and different technology might use different rules. But so it's really, if we're doing whole numbers, it's really 30 to 39 and then 40 to 49. If you have decimals, then this gets a little trickier. Then you would just do anything up to 90, but then 90 bumps over into the next bar over. Okay. So that goes to the right. Now the next one is the 90s. So we have 94, 95, 98. So there's 3 in that bar. And then we do have 100, which I'm assuming is a perfect score. Now this is what can look a little funny to people. Remember I was saying how if it's at that right endpoint, it goes into the next bin. So this kind of looks like the scores go up to 110, but that's not necessarily the case. So different technologies handle this differently. So sometimes you might see where it won't go over the max and it'll actually put the max in this bar. So you might see this point, this one right here, depending on, and we'll look at what Staplet does in just a second. You might see the last, if it goes over the max, or same thing with under the min, but if we're putting to the right, then it's going to only be on the upper side that's a problem. You know, different programmers handle things differently and different statisticians handle things differently. So just something to be aware of. So if this right now is going above the max, so kind of looks like they go to 110, but you might say, oh, well, there was 100, so that's what that square is for. But some technologies will put it up there. Okay, so we were getting at shape, right? So this gives us an idea of the shape. And what we can do, I'll show you in a future video, is we kind of connect these bars. I'm going to connect the corners of these bars like that. And that is a particular shape. And we will talk about different vocabulary words for shape in a future video. But let me do a similar thing. Let me move this. I have to take my stem and leaf on its side. It's really the same shape, right? Because these are like bars. They're just written in numbers instead of squares. So it's really the same shape, it's just on its side. And you could think of these as bars, but what's interesting about the stem and leaf plot is you can see the actual data values. So you can see, oh, I have a 70. Let me put it back. You can see I have a 70 and a 76. I have a 98. So whereas here you don't know, oh, well, it's somewhere between 30 and 40, right? Unless you go back to the actual data set, data values, you don't know. Okay, so these are types of graphs for a quantitative variable. We're just looking at one variable at a time right now. Types of graphs for a quantitative variable, and that way we can start looking at the shape. Okay, so in the next video, I'm going to show you how to do this with technology, and we'll compare how this looks with our graphs. Okay, I'll see you in the next video.